Welcome to Math Online Academy. In this lesson, we want to talk about power index. In our last discussion on indices, we talked about division of indices, and we said that if we have two indices, for instance, if we have 2 raised to power 4 over 2 raised to power 2, that we do the division this way. We divide the bases. The bases are these two, and then the powers, we subtract them, so it becomes 2 raised to power the numerator minus the denominator, power of the numerator minus power of the denominator. This is numerator and this is denominator, so it becomes 2 raised to power 4 minus 2. And we also looked at advanced examples on this. Now today we want to see power index. Power index is talking about how we work about the power of or power in indices. We have 3 types of this power index. Now let's look at this one where we have multiplication of powers. For instance, where we have 2 raised to power 2 in brackets. The brackets also has power, let's say power 3. It becomes, if we have something like this, what we do is just that we multiply the powers. We say 2 times 3, that is, the base remain the same, so 2 raised to power 2 times 3 is 6, so it becomes 2 raised to power 6. We can find the value of 2 raised to power 6 to get the final answer, or we can leave it this way. Also, in this multiplication of powers, if we have 2 raised to power 2, or we have another form whereby we can have, let's say that we have A, B, all raised to power 2. Now, what this means is that you use the power and multiply everything inside, so it becomes A raised to power 2 and then B raised to power 2 also. Now that is how to clear the brackets that contains a power, A raised to power 2 and B raised to power 2. Another example, if we have A raised to power 2, B raised to power 3, then both of them raised to power 2. Now what is going to be is, we use the 2 outside the bracket to multiply the powers inside, which is now A raised to power 2 times 2. That is this 2 coming to this one, and the 2 also comes to this one. So A raised to power 2 times 2. Then B raised to power 3 times 2. So this is going to be A raised to power 4 and B raised to power 6. So this is the answer. So this is how to multiply powers in indices. Then we have negative index, which we have also talked about when we talked about the index notation of negative powers in our previous lesson, the lesson on index notation. We said that if we have a number like 2 raised to power minus 2, if the power is minus, we write 1 and then we write the number, raise it to power positive. So this is going to be 1 over 2 raised to power 2. When we put 1 over, then we remove the minus sign. So the 1 over is taking care of the minus sign. So this is how to express the index of a negative power. We have talked about this one extensively in our last or previous lesson on index notation. You can review the lesson if you need some further assistance on that. Then we have root power. This is very important. In root power, for root power, if you have, let's say that we have 2 raised to power 3 over 2. 2 raised to power 3 over 2. Or let's say that we have 4 raised to power 3 over 2. Four raised to power 3 over 2. What this is going to be is, we write the 4, then we raise it to power of the numerator. This one on top is called numerator, and this one down is called denominator. We raise it to power the numerator, so 4 raised to power 3. Then we find the roots of it. Now, if the root is 2, we leave it. So this is root. This 2 that is here, we put it here. But when 2 is what is here, we always leave it as, that is the square root. When it is 2, we don't normally write anything here. But assuming that this is 3, or assuming that this is 5, then we raise it to the power 3, and then the 5 that is down, that is the denominator. At the back of the root, we write it. So it becomes the 5th root of this number. So what we are going to do is that we find the power of 4 to 3. That is 4 raised to power 3. Then we find the 5th root of it. So generally, we express the root power as, don't worry, I'm going to give you more examples. Generally, we express the root power as, if we have a raised to power n over m, it is going to be, we write a, then we raise this to power of the numerator, which is n. Then we find roots of this value, root of it. Then whatever that is down, which is the denominator, we write it at the back of the roots. So if 1 is the numerator, you raise the a to power 1, and if 2 is the denominator, you write 2 here. But normally, if it is 2, 2 here means square root. We don't always write the square root, that is the 2. We just write square root symbol, which is this. But when it is from 3, 4, 5, that is from cube root. To show cube root, you must put the 3. For 4th root, you put 4. For 5th root, you put 5. For 6th root, you put 6. But when it is 2, you don't write anything. So this is how to express it. So whatever that is the denominator, you put it at the back of the root, and whatever that is the numerator, you raise the base by 8. Now let's see more examples on this. If we have 2 raised to power 1 over 2, this is going to be, we write the base, which is 2. Then we raise this to power of the numerator, which is 1. 2 raised to power 1. Then we write the roots. Then it is 2 that is here, so we don't have to put the 2 here. We are not putting anything here. So we leave it empty to show that it is square roots. We already know that it is square roots. By just leaving it empty, we already know that it is 2 that is supposed to be here. Okay, so this becomes 2 raised to power 1 is 2. So this is the answer. Now, if we have 9 raised to power 1 over 2, this is going to be, the base is 9, then the numerator is 1, and root, we still have 2 here, so we don't have to put anything there. We leave it as square roots. So this is equal to root 9. Root 9 is equal to 3. So the answer is 3. Now, what if we have 2 raised to power 1 over 3? This is going to be This is going to be 2, which is the base, raised to power 1, then the roots, and then we write 3, which is equal to 2, 3. So this is the answer. Now, consider where we have if we have 2 raised to power 1 over 2 times, they can combine 2 times 2 raised to power 1 over 3. This is going to be roots. First of all, when we have different roots combined like this, that is when the power is fractions this way, then what we are going to do is that we multiply the bases just like we do when we see 2 indices and they are separated by multiplication sign. We multiply the bases and then add the powers together. So it becomes 2 raised to power 1 over 2 plus 1 over 3. Now this is going to be 2 raised to power, the LCM is 2 and 3, that is 2 times 3. We have 6. So we have 6 divided by 2 will give us 3. 3 times 1 will give us 3. Plus 6 divided by 3 will give us 2. 2 times 1 will give us 2. So this will give us 2 raised to power 5 over 6. So this becomes the final power. So when we get to this one, that is the final power here, we now use the power roots or the root power to get the final answer. So it becomes we write 2, we raise it to power of the numerator, which is 5, and then we find the roots. 6 is the denominator, so we write the 6 outside the roots. So it becomes the 6th root of 2 raised to power 5. We can find the 2 raised to power 5 and see if it has a 6th root, or we leave it this way. So this becomes the answer. Now let's see another example of this. If we have 3 raised to power 1 over 3 times 2 raised to power, 3 raised to power 1 over 3 times 2 raised to power 1 over 3. This is going to be, since we have the same base, we take one of the bases, which is 3. Now 3 raised to power, now we add the powers together. So this is going to be, the LCM is 3. 3 divided by 3, we give it 1. 1 times 1, 1. 3 divided by 3 again, we get 1. 1 times 2 is 2. So it becomes 3 raised to power 3 over 3. So this gives us 3 raised to power 1. Here we don't have any roots to find. So the final answer is going to be 3. But assuming that we get to this place and we have a fraction, then we raise the base by the numerator and find the roots to the denominator. So they can actually combine different laws of the indices in one question. You solve the first one using the or you solve the first step using the first law or one of the laws and solve the remaining steps using another law of the indices. So this is a typical example of that, where we use the law of multiplication to get the first stage, and then we use the law of power or index power or power index to get the second stage of the problem. Now, let's also look at this example that may look somehow tricky. If we have 2/3 all raised to power 3. Now, once we have anything inside brackets, use anything outside brackets, use it to multiply everything that is inside brackets, whether the thing inside brackets is addition, subtraction, division, or multiplication. So here it is division, so we are going to say 2 raised to power 3 over 3 raised to power 3. So with this, you start to solve. If what you have inside brackets, like I gave in the other example, is, let's say we have 2 times b, then it is going to be 2 raised to power 3 times b raised to power 3 so this is the power when it involves division of number inside brackets. So no matter how it comes, once you see power outside brackets, use it and multiply individually everything that is inside the brackets, no matter the arithmetic sign that is used to separate the things inside the brackets. Okay, with that, we now move to, let's see, 0 index, 0 power. 0 power, this one is simple. And this one says that whenever we see anything raised to power 0, that thing is going to be 1. So a raised to power 0 must be equal to 1. 1000 raised to power 0 is equal to 1. 1 million raised to power 0 is equal to 1. 1 raised to power 0 is equal to 1. So 20 raised to power 0 equal to 1. 25 raised to power 0 equal to 1. 1 raised to power 0 equal to 1. 2 raised to power 0 is equal to 1. So this is the power when we are working with power of 0. So with this, we have actually come to the end of all the laws of indices. Now you may see something like combination of different laws of the indices in your exam, like the one we did when we solved this example where we combined multiplication law and power law. So this is the kind of thing or question you see in your exam. They'll combine different laws and ask you to find something. So you just break it down. You find the first one. Look at the first one that you're going to do first. If you see multiplication and then the power, you first of all have to do the multiplication and then you do the power. And let's see that, let's have this example. if we have this example, root 4 raised to power 1 over 2. Now, we know that trying to find the root of this value inside, it will be very difficult. We don't even know where to start. So we have to start with the one inside by using the law, the index power. So we find this one first by saying this is equal to root of 4 raised to power, the numerator is 1, 4 raised to power 1, then root of, so this is a root inside root, so what is here is 2, but because it is 2, we don't normally write 2, so we remove it, so it becomes the square root of 4 raised to power 1, which is equal to square root of 4. 4 raised to power 1 is 4. Square root of 4 is 2. So we now get find the square root of the one inside, which is 2. Now with this, now it becomes very easy. So you can use your calculator and find the square root of 2, or you leave it this way as the answer. So when you see different laws combine, you break it down and solve it step by step. Now let's see our assignment. So this is the assignment. You evaluate this 64 raised to power 2 over 4, 7b raised to power 3 minus 6b raised to power 2 all brackets power 2 and 4c raised to power 2 all brackets power minus 4. So evaluate this and submit your assignment. Thank you.